The first question here is, define the term solution. How many types of solutions are there? Now, this is very simple question where we say define the solution. Okay. Solution is nothing but a mixture. Okay. Mixture of, and when we talk about solution here in 12th grade, we are talking about binary solution. So what is the difference between solution, normal solution and binary solution? Means there will be only two components in binary, but solution has to be homogeneous. So this is the keyword your examiner, your teacher will be looking for. Whenever we are talking about solutions, you must write homogeneous. So it is just homogeneous mixture, nothing else. So I would say Devyansh has given me correct answer. Okay, in the chat. Utkarsh, there are many types of solutions, right? There are total 9 types. So when we say how many types, there are 9 types. Okay, so you will say it is homogeneous mixture of 2 substances. Okay, there can be more, so you can write 2 or more substances, and depending on their composition, there can be 9 types of solutions. So first, in the definition of solution, you will write it's a homogeneous mixture of 2 or more substances. That's it. Okay, how many types? There are total 9 types. Why there will be 9 types? Because in one case, solvent, if I talk about solvent, if solvent is gas, there are 3 possibilities. The solute can be solid, liquid, gas itself. So this is 3, set of 3. Then solvent can be liquid, and then again you will repeat solid, liquid, gas can be dissolved into liquids. So solute is normally which is smaller in quantity, and solvent is one, this is normally greater in quantity. And then you can say solvent is solid. Again, there are 3 possibilities. Solid in solid, that is alloys. Solid in liquid in solid. When we talk about liquid in solid, this is specifically, for example, mercury is a liquid. Okay, mercury is a liquid that is with sodium. So you know that there is mercury sodium amalgam. That is one example of that. Okay. Then there can be gases into solid. Gases into solid are those ones where, if you remember, in 11th grade we talked about. In 11th grade we talked about hydrogen economy. Do you remember that term in hydrogen chapter? And hydrogen economy was how it is stored, how it is transported, how it is used. So in storage, there was that it is stored in palladium. So there are spaces within the molecules of palladium where hydrogen can be stored. So in the interstitial spaces within the solids, gases can be mixed there. So that will be a solution of gas into solid. Who has asked this question? Utkarsh, liquid in liquid, no, we won't say that, call that emulsion, because liquid in liquid, if you say alcohol in water is liquid in liquid, but it's not emulsion, it is solution, simple solution. Okay, not emulsion. So these you will write. Now if I talk about solid into gas, okay, so it can be camphor, right? Camphor is camphor sublines. Okay, so if camphor sublines, it remains in the type of solid particles, and when those are mixed with, say, any gas with which it does not react, for example nitrogen, so that will be camphor plus nitrogen will give you solid into gas. Then liquid into gas can be chloroform and nitrogen mixture. Okay. This is liquid, this is gas in greater quantity. Even moist air is an example of this one, because air is nitrogen, oxygen, etc., and moisture means H2O. So H2O is liquid in air, so moist air is also another example. Gas in gas, anyway, there are many examples. For example, air is nitrogen, oxygen and nitrogen. Okay, so you will not write nitrogen and oxygen, you will write oxygen and nitrogen. You will write solvent later on. Nitrogen is in greater amount, oxygen is in a smaller amount, so oxygen is solute, nitrogen is solvent. Then this one, solid in liquid. So solid in liquid example will be, for example, you mix sugar into water, you mix salt into water. So this is the easy one. Liquid into liquid, I have already told you. For example, you mix alcohol and water. Then gas into liquid, for example, Coke, Pepsi, fizzy drinks, etc. You know, those ones are. So oxygen dissolved in water or fizzy drinks, all those. Okay. Solid are basically the alloys. Okay. Alloys. So you have a copper gold alloy. Gold is actually, the ornaments are made of copper gold alloy. Copper is mixed with gold, otherwise it is so malleable and so ductile that you will not be able to make ornaments. So alloys, for example, copper and gold alloy. Yes, amalgam is again, amalgam is a mixture of mercury with any other metal. Although this term is now being used for linguistic purposes also, in terms of saying any mixture. Okay, so if we mix two things, we say amalgamation of these two things. But if I talk about scientifically, amalgamation means mercury with any other metal. That is amalgam. Right. So I hope, because these ones were easy, so I have not specifically written, but all other I have written. So here, hydrogen in palladium, we have talked about it in hydrogen economy. Next one, suppose a solid solution is formed between two substances, one whose particles are very large and the other whose particles are very small. What kind of solid solution is this likely to be? So you can understand it from your knowledge of solid state, because you have done solid state. So suppose you have this type of structure. So these are very large, and there are very small particles as well. So small particles will be in the spaces therein. And what is the term for that? You know that. Tell me the term used if the particles occupy the space in between the large particles. What do we call it? No, Pratham, that is not that. You are close, Pratham and Sab, but Devyansh, yes, you have given me correct answer. Prakriti given me correct answer. Pranav given me correct answer. Interstitial spaces. These are called interstitial spaces. These are voids, but spaces, interstitial spaces. So this type of solution is known as interstitial solution. That's it. Simple. Because these spaces are interstitial spaces. So you will say the kind of solid solution, answer will be interstitial solid solution. This is the answer, and it is asked in 1 mark. You just need to know this term and you get 1 mark. Okay. Today there was chemistry paper of 12th grade, and many students have done full. Okay, 35 out of 35. All the students very happy. So the paper was very good for almost all students. Okay, I have not received response from 2 students, but whatever I have received response, very, very good. So it means you can do 34, 35 out of 35 marks, but this year, you know, this will be 70 again marks. So 68, 69, 70 out of 70 is not tough. It's easy. Next, concentrated nitric acid used in
the previous question.
Yes, yes, I can. Done?
Yes, sir.
Okay. Tanishi, the test is at 9 p.m. online test tomorrow, and offline class will be at the center 5 p.m.
Only
class will be offline. Okay, I will keep the class online as well, tomorrow's class, but test will be online only. This question is very important question, and everyone should pay attention. Very frequently asked in your exam. Okay, very frequently asked in your exam. Concentrated nitric acid used in the laboratory work is 68% nitric acid, and the point is, this is something you have done in your 11th grade as well. Same question you have done in your 11th grade. Okay, acid by mass in aqueous solution. So you have nitric acid HNO3 in laboratory, and it is 68% nitric acid by mass. It means 68 grams is present in 100 gram solution. By mass means 68% by mass means 68 grams HNO3 is present in 100 grams solution. This is what the information given here. What should be the molarity of such sample of acid if the density of the solution, remember density of solution is given. Yes, density is always of solution. So you should not use it for 68. That is the mistake usually students do. If it is required, density is related to solutions. Obviously, it is related to of this 100 gram, not of 68 gram. Utkarsh, yes, right, good. Now, if molarity is asked, you need volume of the solution.
Certainly.
And you can calculate the volume of the solution, because you know, if you assume, obviously you will be assuming the mass of solution 100 gram, because then you can say HNO3 is 100 gram as per the information given. Yes, Utkarsh, molar mass we will need. So what is molarity? Molarity is capital M, number of moles of solute divided by volume of solution in liters. And number of moles of solute you can get because you know how much HNO3 is there. Solute is HNO3. And what is the molar mass of HNO3? 63. So number of moles of HNO3 will be given mass divided by molar mass. I'm not writing the formula. You should be able to understand it by now. number of moles, given mass divided by molar mass, given mass 68 gram, because we have assumed the solution is 100 gram, and molar mass of HNO3 is 63. HNO3, 1 plus 14 plus 16 into 3, 48.
63.
63. Okay. So you got that volume you will get from here, that volume of solution will be, because you know density is equal to mass over volume, volume will be mass over density. So it will be mass over density. So it will be mass is 100 gram and density is 1.504 grams. These many milliliters, and this is where students make mistakes. Okay. Because the density is given in gram per milliliter. And this is gram. So this is 100 gram. This is gram per ml. So obviously the answer will be, this volume will be in ml. So don't forget to divide it by 1000 to get it into liters. Otherwise, you are making a mistake. So these many milliliters, that is 100 divided by 1.504 into 1000 in denominator liters. Now you will substitute these values. Number of moles of solute 68 divided by 63, and the volume of solution in liters 100 divided by 1.504 into 1000. So it will be 68 divided by 63 into 1.504 into 1000 divided by 100. 0, 0, 0, 0 got cancelled. So it is actually 68 into 15.04. I have used this 10 there, okay, remaining, divided by 63. Now you can get the answer. If it is MCQ type question, you will not solve beyond it. Why you will not solve beyond it? Because 68 divided by 63 will be approximately 1.1 or 1.2, right? And 1.1, if you see this one, this is 1.5 times. Okay, 15 means 15 times, or if you consider 1.5, it will be 1.5 times. So if you have 1.5 times will be 1.5. If you have 1.1, 1.5 times will be approximately 1.6. So answer should be 16 point something or approximately 17 in the options available. But here, if you solve, it will be exactly 16.24. Okay. Yes, Pranav, correct calculation. Okay. Then you have, I've got some more answers. That's okay. Yes, Ariman, Kasak, Utkar, Pranav, correct answer. Any confusion here? What we have done? We have simply applied the formula of molarity, number of moles divided by volume of solution in liter. Number of moles we have obtained by given mass divided by molar mass. Volume we have obtained from the density given, and the mass of solution we have assumed. Next one. A solution of glucose in water is labeled as 10% weight by weight or mass by mass, same thing. Okay. You can get weight by weight or you can get mass by mass. And this is where students make mistake. I will tell you those points where students make mistakes. What would be the molality and mole fraction of each component of the solution? Each component of the solution means glucose and water. The problem where students face, or I would say students make mistakes, molality considers the mass of solvent in kg. So So if it is written 10% weight by weight, it means if you assume it is 100 grams total, then glucose will be 10 grams and water will be 90 grams, not 100 grams. And that is the common mistake. Students take 100 gram because they normally have the feeling that out of 100, 100 is solution. And because most of the questions are related to molarity, I have seen students making mistakes here. So that is the case only if you know that, and if you can figure that out, then you will be able to answer the question very easily. Yes, correct. Devyansh, Samad, yes. So if you want to calculate molality, molality is number of moles of solute divided by the mass of solvent only in kilograms. So molality, lowercase m, is number of moles of solute divided by mass of solvent in kilograms. Number of moles of solute will be, I have told you that you need to remember the molar mass of glucose 180, okay, 180. So it will be given mass divided by molar mass, 10 divided by 180. And mass of solvent will be this in grams divided by 1000 because we have to get it in kilograms, and you get the answer. So easy. So it will be 10 divided by 180 into 1000 divided by 90. Right. And when you calculate, you will get 0.618. Then read the question. If there is anything else, yes, mole fraction is required. Okay. What would be molality and mole fraction of each component? If the density of the solution is 1.2 gram per ml, then what shall be the molarity? Okay, then we have to calculate molarity as well. But first we need to calculate the mole fraction if we can. Yes, Shashwat, good. So mole fraction we can get very easily because number of moles of glucose will be its mass divided by molar mass, and number of moles of water will be its mass divided by its molar mass. So obviously you will have to then apply the formula that the mole fraction of glucose will be N. I would say this N1. I would say this one as N2. So this one will be N1 divided by N1 plus N2. And mole fraction of H2O will be 1 minus N1. Oh, sorry, Chi1. This one, glucose. Sum of mole fractions is always 1. So that's why you don't need to calculate Chi2, the mole fraction of water. You can get directly by subtracting from 1. So you have to do these calculations, okay? And this will be an assignment. Basically, there will be it will be divided in 2 or 3 on the website, and you need to submit all these questions in your handwriting, NCERT questions later on. So make sure that you understand all bits here. Then the next part is what will be the molarity if the density of the solution is this one. What is basically we need extra for molarity? We need volume of the solution, and density is given. So obviously from mass you can calculate the density of the solution. But my question is, and you will respond in the chat box, what you will consider when you calculate the volume, whether you will consider 10 gram, 90 gram, 100 gram. Mass you will consider, okay, Pranav, Pratham, Shashwat, good, Vedant, Sabya, Kasak, Utkarsh, Pratham, again, Ananya, Divyansh, okay, fine. Because we are not now talking about solution, it will be 100 gram. Don't consider 90 gram. So for molarity, I will say molarity is number of moles of solute, which will still be same 10 by 180 because glucose is 10 gram. But here volume will be mass over density. And it will be divided by 1000. Don't forget that, because 1.2 was given as gram per ml. You need to use it in liters. So it will be 100 divided by 1.2 into 1000. So it will be equal to 10 into 1.2 into 1000 divided by 180 into 100. So it will be 12 by 18, and 12 by 18, you know, is 2 by 3 means 0.667. It will continue 0.666. So this will be the molarity. Yes, Sharma, is that clear or not?
Yes, sir.
Okay, Ananya,
Yes.
Samad,
So it's clear.
next. How many milliliters of 0.1 mHCl are required to react completely with 1 gram mixture of Na2CO3 and NaHCO3 containing equimolar amounts of 2? This requires your knowledge of mole concept, stoichiometric ratios as well, and the reaction of HCl with the sodium carbonate and sodium bicarbonate, both. Question is easy. Question is not tough, but you should be clear about the stoichiometric ratios and what it means by equimolar, etc. I'm just dividing the question into few parts. It says how many milliliters of this required. And I have told you, however, I won't be doing that way, but you can do that way also. What is this product? Whenever we multiply the molarity with volume, what do we get?
Moles.
Yes, good.
Number of moles.
Number of moles, right? We get.
Oxygen.
Right. Kasak, yes, equimolar means equal moles, so we will be equating moles. That's good observation, right? Are required to react completely with 1 gram mixture. So mixture total is 1 gram. So if I say this is x grams, this will be 1 minus x grams.
Yes.
And this x gram is some moles, and this 1 minus x grams will be some mole, but those moles will be equal. So here moles will be x divided by given mass divided by its molar mass. So molar mass of sodium carbonate Na2CO3, 2 into 23, 46, 12 plus 48. 50 plus 46, 96. No, 60 plus 46, 106. Okay, 106. So it is 106. It will be equal to the moles of 1 minus x divided by its molar mass NaHCO3. So it will be 23 plus 1 plus 12 plus 48. 48 plus 12 again 60 plus 24. 84. So up to here, everyone clear or not? It is written equimolar and total mixture is 1 gram. So if one is x, the other one will be 1 minus x, and then we will calculate their moles. We will equate their moles. Now this is linear equation in one variable, which you can solve easily. So from here, you can get the value of X. So X will be 84X equals to 106 minus 106X. So 84X plus 106X equals to 106, means X equals to, so it will be 84 plus 106. 106 divided by, it is 84, not 89.
Sir, 190.
190, right? 190. 106 by 190. So you will have to calculate, it should be slightly greater than 0.5. Okay, Kasak, thanks for calculating it for me. It will be 0.56 approximately. Okay, the value of X. Now, if you got the value of X, you can calculate the number of moles. And why do we need a number of moles? Because the reactions, chemical reactions happen in terms of moles, not in terms of grams. So I'm writing the reactions first so that you understand why I am calculating the moles. So this HCl will react with Na2CO3. So Na2 sodium carbonate will react with HCl. It will produce NaCl plus CO2 plus H2O. Okay. Now if you balance, it will be 2 NaCl plus CO2 plus, here it will be 2, because it is 2 chlorines. This is the balanced equation. Okay. And then this sodium bicarbonate is in the mixture. This will also react with HCl. So NaHCO3 will react with HCl, and it will again give you NaCl, CO2 and H2O. And this is already balanced. The question is, how many milliliters of 0.1 m HCl are required to react completely? It means I need to know how many moles of HCl in total will be required. I know that I have few grams of Na2CO3 and few grams of NaCO3. From there, I will now calculate the moles, because I know that stoichiometric ratio, 1 mole of Na2CO3 reacts with 2 moles of HCl. So whatever moles I get here of Na2CO3, double of that HCl will be required. So I know how much HCl will be consumed, or how many moles of HCl will be consumed with Na2CO3. Similarly, these many moles when I get after substituting the value of X, this is 1:1 ratio. So whatever those moles are there, same moles will be used for HCl. So I know from here how many moles used, from here how many moles used. I will add these. So I will get total number of moles of HCl. And then, as you told me, when I asked that molarity multiplied with volume gives you number of moles. So I will equate this to number of moles. These. I know the molarity 0.1. Volume is not known. And moles I will substitute from here. So I will get the volume. Okay. But from here, I will get the volume. I might get the volume in liters, because normally it is calculations are in liter, because if I have this 0.1, mole will be equal to number of moles will be equal to molarity into volume in liters. Why? The reason is very simple. The reason is very simple, because if I multiply molarity and volume, molarity unit is mole per liter. So here it will be in liter, only that I will get mole. Okay. So the volume unit, the volume you will get will be in liters. Make sure that you convert it to milliliter, because the question is talking about milliliters of HCl. Is the approach clear or not, everyone? Yes, Vedant, correct. Yeah.
So could you explain the x and 1 minus x part again?
Okay, the question says you have a mixture. You have a mixture and you have some part as Na2CO3 and some part NaHCO3. Total is 1 gram. I have assumed this is X grams. So this will be 1 minus X grams. Is that clear?
Yes, sir.
Right? Then the reactions do not take place in terms of in the ratios of grams. They take place in terms of moles. So I will calculate their moles. Moles here will be given mass, this one, divided by its molar mass, which is 106. Here I have number of moles given mass 1 by x, 1 minus x divided by its molar mass, which was 84. Is that clear why I have done so?
Yes, I got it.
And then in the question it is given this is equimolar solution. So it means these moles are equal. From here I got the value of x 0.56. Clear? So 0.56, the moment I got these values, I will substitute this value 0.56 divided by 106. These many moles are there of both. Okay. So it will be same actually. If you calculate this part or this part, you will get same answer. So 0.56 divided by 106, you will get the exact moles, equimolar solution. So moles of Na2CO3 and NaHCO3 will be same. And when you solve this, just a second, give me a few seconds. 0.56 divided by 106, you will get 0.00526 approximately. So in both cases, it will be 0.00526 moles because it is equimolar solution. Now come to the reactions. When I have reaction with Na2CO3 reacting with HCl, it will give you NaCl plus CO2 plus H2O. And I have NaHCO3 also reacting with HCl. It will give you NaCl plus CO2 plus H2O. You are not bothered about, this part. You are bothered about only what is the ratio here. What is the ratio here? So the ratio here is 1:2. So if I am using 0.00526 moles, here twice of 0.00526 moles will be used. This is equimolar. So here also you have 0.00526 moles present in the mixture. And here the ratio is 1:1. 1 mole of this one reacts with 1 mole of this one, means here same number of moles will be used, not twice. So I got total number of moles of HCl consumed here, which obviously will be 3 times 0.0526 moles. So you will say total moles of HCl will be 3 times, you will say 2 into 0.00526 plus 0.00526. Let me just do calculation. Give me a few seconds. 3. It will be 0.01578 approximately. Okay, 668. Yes, correct. Okay. Now you know these many moles of HCl are used. Now you will apply the formula. The number of moles is equal to molarity multiplied by volume. So you will say M into V is equal to number of moles. M is 0.1 into V, number of moles 0.01578. It means volume is 0.01578 divided by 0.1 liters. That is 0.1578 liters. That is 157.8 milliliters. That is the answer. Vedant, is that clear or not?
Yes, sir.
Anyone? If it is not clear, Ananay?
Yes, sir. Sir, so in the final part, sir, from each of the solution, we will add up the total mole.
You are saying number of moles of hydrochloric acid?
Yes, sir.
Yes, we will obviously get the moles which react with sodium carbonate and the number of moles which react with sodium bicarbonate. And then we will say how much volume of HCl will be required total.
Sir, can you please just explain why the mass of Na2CO3 and NaHCO3 is equal to that of HCl?
Not the mass. I'm saying moles because
Yes, sir, the mole.
right in one case it is if nothing is written here, it means it is 1 mole. Okay, and how many moles are there? 2 moles. So in this case, if I have X moles here consumed, double the moles of this one will be consumed. Is that clear? Because the ratio is 1:2. 1 mole, 2 moles. So for this reaction, the moles of HCl will be double the moles of sodium carbonate. Are you getting it what I am saying?
Yes.
Okay. So we will get, and I have already calculated that we have these many moles of sodium carbonate. So double of that will be required for HCl. Same number of moles of NaHCO3 are present because these are equimolar mixtures. But ratio in this reaction is 1:1. So same number of moles will be required here of HCl. Was that your question?
Yes.
So from that you got the total number of moles of HCl used. From number of moles you will calculate volume. Okay. If you don't apply this one, just apply the formula of molarity. Okay. You can say molarity equals to, as molarity is equal to number of moles divided by volume of solution. From here you can get M into V equals to N.
Okay, sir.
Next question. A solution is obtained by mixing 300 grams of 25% solution and 400 gram of 40% solution by mass. Calculate the mass percent of the resulting solution. Now something is assumed here. What is assumed? The assumption is that we have same solute and same solvent, which is not written here. So in this case, the solvent is 25%. And in second case, the solvent is 40%. In final solution, you have been asked what will be the mass percent. And it is very easy. Why I'm saying it is very easy? Because if you understand it diagrammatically, we are saying that you have 300 gram of solution and you have 400 gram of solution. Here you have 25%, here you have 40%. So total you have 700 grams, remember. So from here you got total 700 grams. If you can calculate in this total 700 gram, how many grams this 25% is equal to, how many grams this 40% is equal to, then you will be able to get the mass percent, because mass percent is mass of solute divided by mass of solution into 100. That's what you do. So this 40% of 400 gram will be how much? 40% of 400 will be how much? 160, right? 25% of 300 will be how much? 75. So how much this total? 160 plus 75. Solute I am talking about. Okay, this is solute. Okay. It is 235. 40 plus 35 is 75. 160 plus 40 plus 35. 235. Okay. So it means mass of solute divided by mass of solution into 100, 235 divided by 700 into 100, that is 235 divided by 7. 7 3s are 21, 25, so again 7 3s are 1 again 4, 47 5s are 35, then 7 7s are 49. Okay, so this is mass percent of solute. Okay, and because it is asked calculate mass percentage of resulting solution, it means you have to calculate for both, for solute and for solvent. So if for solute, this is mass percent of solute, write it down. Mass of solute divided by mass of solution. And mass percent of solvent, obviously subtract from 100, because percentage is always 100, maximum percentage sums up to 100. So mass percent of solution mixing gram by mass means solvent. 100 minus 33.57. 100 minus 33 will give you 67, minus 57 you have to do. Okay. You will get the answer. $5,700 minus 57.43%. Many correct answers I have received. Okay, Kasak, Devyansh, already giving me correct answers, and few steps also I'm getting correctly. Utkarsh, Kasak again. Pratham, yes. Good. Devanshi, yes. Tanya, yes. Utkarsh, yes. Good. Good. Very good. Now next solution, next question. Basically, when we talk about antifreeze solutions, why do we call these antifreeze solution? Because if you know, we talked about depression and freezing point. When we add a solute in solvent, we observe depression and freezing point. So if there is depression and freezing point means, suppose if I talk about water, okay, and it will get frozen at 0 degrees Celsius. So what I can do in cars, etc., it is used that some antifreeze is used. So if I have now a solution, I add some solute into water. So there will be depression in freezing point. Depression means it will go below 0 degrees Celsius. So say it is minus 5 degrees Celsius. It means if the temperature in hilly areas, etc., if their temperature is minus 2 degrees Celsius, even then the water will not freeze, because now its freezing point is minus 5 degrees Celsius, not 0 degrees Celsius. So these type of solutions are known as antifreeze solution, means they delay or they avoid the freezing of the solution. So this is used, this is basically the application of depression and freezing point if we add a solute in solvent. So the question is nothing but you have done related to these questions. You have used the formula already. Antifreeze solution prepared from 222.6 grams of ethylene glycol and 200 grams of water. Calculate the molality of the solution. If the density of the solution is this much, then what shall be the molarity of the solution? Something you have been doing again and again from here. So what you will do, you will first calculate the moles, because you have to calculate the molarity of the solution. Sorry, molality of the solution. Molality will be the number of moles of solute divided by the volume, sorry, the mass of the solvent in kilograms. My question is, which one is solvent? Don't be in a hurry, just think and answer. What is a solvent? Whether ethylene glycol is solvent or water is solvent. Which one is solvent? With reason, with reason.
The water.
Write in the chat box with reason, with reason.
Sir, can you repeat the question?
My question is, Kasak correct, Arna correct, Pritham no, Tanishi no. My question is, what is solvent here? What is solvent in the given question? You need to give me reason, otherwise I won't accept it. Pranav, yes, correct answer with reason. Pratham, no. Devyansh, no. Tanishi, Tanishi, you need to explain that. In fact, it is contrary to what is written if you write in that way. So Shashwat, no. Devanshi, no. The reason is not correct. Sab, give me the reason. Prakriti, no. Okay. Sab, okay. But that is, if that is not given, suppose only molality is asked, then density is not given. How will you identify? Okay, no, Tanya. The reason is, you will consider it in terms of moles. You will consider in terms of moles, because moles will decide the particles. Right. Try to understand what I am saying. Try to understand what I am saying. Suppose you have, I'm giving you just examples. Suppose you have glucose or you have sucrose and you have water. And what a solution will look like, suppose, or you can say anything which is not water, might be carbon, okay? Carbon, simple carbon particles, okay? And suppose carbon you have 288 grams, okay? And sucrose you have 342 grams, okay? And you will say, if I consider the grams, you will say this one is solute, this one is solvent. You will say, I'm not saying, okay? But we can say that. But I have to consider the particles, because the solution will be in terms of particles. How many particles are there of one as compared to particles of others? That will decide which one is in greater quantity. And particles are proportional to the number of moles, because number of moles, 1 mole is equal to 6.022 into 10 power 23 particles, 2 moles, 12.044 into 10 power 23 particles. Okay? So moles ratio and particles ratio is same. So calculate the mole. Moles here will be given mass divided by molar mass. Molar mass is 340. So approximately just 342, sorry. So it will be 1 mole. And carbon, it will be 288 divided by 12. 24 moles. So if I have here 6.022 into 10 power 23 molecules of sucrose, particles of sucrose, I will here have 24 into 6.022 into 10 power 23 molecules of carbon. It means carbon is a solvent, although it is in mass in lesser quantity. Is that clear or not? What I am saying? Or if still there is any problem, let me know. Same concept you will apply here. You will say approximately how many moles in 222.6 grams of ethylene glycol. For that, you will have to calculate the molar mass of ethylene glycol. Ethylene glycol molar mass will be 12 into 2 plus 6 plus 16 into 2, 62.
Sir, 62.
And water, 18, you know that. So number of moles of ethylene glycol will be 222.6 divided by 62. And number of moles of water will be 200 grams divided by 18. Which one is greater? Obviously, this one is greater, much greater. So water, although by mass in less quantity, is solvent. Ethylene glycol is solute. So now we will proceed. Once this is clear, we have to calculate the molality. Molality will be the number of moles. Here molality will be number of moles of ethylene glycol divided by mass of water in kg. Means given mass divided by molar mass of ethylene glycol divided by mass of water in kilograms. Means 222.6 into 1000 divided by 62 into 200 means 2226 divided by 62 into 2. Simplify that. Kastak says 17.9. So I'm writing that. Eventually, I don't have answer of this one. So I'm assuming because it should be close to 17, okay, or 18. So Kasak's answer is correct. Yes, Arna. If it is 17.95, so it is more.
Well, the answer is 17.9 only.
Okay, good, good. Ananya, no, it can't be 71.8. Utkarsh, yes, correct. Okay, so it will be 17.9.
Sir, 15.45.
No, it can't be, right? It can't be. The reason is very simple because I have done approximation here, and approximation will be 1113 divided by 62 means it is approximately 111 divided by 62. That's what I will do. And if it is 111 by 62, I can do further approximation. I will decrease something from here. So I can say it is 108 divided by 60. I have deducted similar ratio from both sides. So this is something, if you can learn, it will help you to do approximation very frequently, very easily. And I can see that it will be approximately 18. So that's why I said Kasak's answer was correct, because by approximation, I got 18 approximately. So it can't be 15 point something, it will be approximately 18. Now the next part is, if the density is given, you need to calculate the molarity, and you know that now from density you can get the volume of solution. Volume of solution will be equal to mass of solution divided by density, and mass of solution is both this one plus this one. So it will be mass of solute divided by mass plus mass of solvent divided by density. Density is given 1.072, but this one in milliliters. Make sure you convert it to liters, because we need in molarity, we need it in liters. So you will calculate the volume, okay, V from here. And then you will say molarity is equal to number of moles of solute, which will be same. But here you will say V and then divided by 1000. Because here V you got in milliliters, you will divide by 1000. You will get the molarity. I don't have the answer, so I will have to check how many of you give the same answer, to see whether it is correct or not. Let me see the answer. Just give me a few seconds. Okay, so those who are giving me answer close to 9.1, 9.11, that is correct. The correct answer when you solve this one will be 9.11 m, and this was correct. This answer is 17.95. How much time we have? We still have 10 minutes approximately. So I will move to next question. Yes, Utkarsh, correct answer. Good. Next one. And this question was in your 11th grade also. You can check the chapter, the first chapter, basic concepts of chemistry. This question is there in NCERT, and here also in 12th grade, same question. Okay. And yes, you were able to recall. Good. So this question says a sample of drinking water was found to be severely contaminated with chloroform. So it means this is the solute. Supposed to be carcinogenic. The level of contamination was 15 ppm, means by mass, means 15 grams was present in 1 million. So 15 part in 1 million. So it means question says quantity, or you can say mass of chloroform in 10 to the power 6 grams will be equal to 15 grams. That's what it says. 15 ppm means 15 parts per, means in 1 million, means 15 grams in 1 million grams. So express this in percent, means instead of 10 power 6, get it in 100 grams. That will be mass percent. Apply the unitary method. Hence, mass of CaCl3 in 1 gram, 15 divided by 10 power 6. I'm just applying unitary method, nothing else. And hence mass of CaCl3 in 100 grams, it will be 15 divided by 10 power 6 into 100. That is 15 into 10 power 2 into 10 power minus 6, 10 power minus 4%. Or if you write in specific standard scientific notation, it will be 1.5 into 10 to the power minus 3%. Kasak, yes. Utkarsh, yes. Yes, Utkarsh. Okay, so good. Remember, those students who are active in chat window during the class, they keep answering. Those do not face problem during the examination because they know that they have answered it. They will be able to answer in examination as well. Don't be lethargic here. Just remain active. Utilize this time actively and you will see that you will get very, very good results. Okay. Yes, Anane. Next is determine the molality of chloroform in the water sample. What is molality? Molality, when we consider the mass of solvent in kg. Now just think about it. 1.5 into 10 power minus 3, that is, it is actually 0.0015. Okay, this much in 100 gram. In 100 gram, it is just 0.0015 grams, means it is approximately 0. So negligible as compared to 100 grams. So whatever is the mass of solvent, that is mass of solute as well. Okay. So mass of water in this solution means 10 power 6 grams of the solution, you can consider approximately same. So in such cases, you will do approximation. Yes, Utkarsh. So we will be neglecting 15 grams out of 1 million gram. It doesn't make any sense because 1 million is 1,000,000. So if you add 15 into it, you will have 1,000,015. It will not have any impact there. So it is approximately equal to same. So what we will do, we will say number of moles of chloroform in these many grams. Okay, so you will say in these many grams of water, you have these many grams of chloroform. This is given. So you will say mass of chloroform is 15 gram. Mass of water, you will say approximately 10 to the power 6 grams. Because 15 gram is in the solution itself. Okay. In the water, when we say that is in the solution itself, it is approximately same. So you will calculate the number of moles of this one and you will convert this to kilograms. So molality will be number of moles of chloroform divided by mass of solvent in kilograms. For that, obviously, you need the molar mass of CaCl3. Molar mass of CaCl3 will be 12 plus 1 plus 3 times 35.5. So it will be 12 plus 1 plus 35, 3 is 105 and 1.5, 106.5. So it will be 119.5. So number of moles of CaCl3 will be its mass divided by molar mass divided by mass of water in kilograms. So you will have to divide it by 1000. So it will be 15 into 1000 divided by 119.5 into 10 to the power 6. So effectively, you can say it is 15,000 into 10 to the power minus 6 divided by 119.5. So you can do approximation also because you can consider this as 120 and you can get the answer then. If you consider this as 120, you know that 15 by 12 will be approximately 1s are 20, then 30, 12, 2s are 24, then 60. So it will be 1.25. So it will be approximately 125 into 10 to the power minus 6. That is 1.25 into 10 to the power minus 4 m.